Yeah, hello everybody to our spontaneous lecture. Since unfortunately this talk I announced due to Corona is cancelled. Yeah, what have we talked about? We have talked about in general how monetary policy is provided in our world, and there we introduced the so-called reaction function that we in general assume that the central banks have an eye on, of course, inflation, but also have an eye on real growth on output. And yeah, that also remember the Phillips curve dependence, that of course for this we have a trade-off between these two aims, because due to the Phillips curve we have an inverse dependence between prices and growth. Then we talked about that we could quite good fit the key rates, especially of the United States, with this rule within the Corona, not the Corona, between the last 10 years, the zero nominal interest rates. The fit was not that good, but supposed to be. We will come back again to these dependencies in our times now, where we have again positive inflation rates, positive interest rates. But we will see. Okay. Then this rule more or less only, yeah, changes our general model. We talked about the ISL MZZ model only slightly, that we have now a little steeper dependence between interest rates and the and output, and everything else is more or less the same. Okay, then we talked about the extreme cases. If we had the weights in front of our two targets, prices and output will be 1 or 0, that we then have, of course, inflation targeting or output targeting, while the importance of the output target became more and more important, and now maybe we have a backswing since we have these huge inflation rates over the last 2 years. So both extremes are actually relevant in our view. And then we came to what we call then optimal rules, and about these optimal rules, that the central bank is minimizing some loss function. About this we will talk today. But before that, since this is quite related, here we are talking about some rules. So where we say, in order that we can make good expectations for the future in the framework of an economy, there we quite often find that we give ourselves in our society some rules. And for this, we want to talk about other rules, not in monetary policy, but in fiscal policy, and also their dependence on aggregate time series. And two slides here you have already seen in your introductory courses, and maybe you remember these. These are the interest rate developments of all Eurozone member countries. And there we talked about that before the introduction of the euro, we had here interest rate differentials. So Italy has had to pay more interest for their government bonds. I think this is a brown one here, Italy, than Germany was down here. Well, this is not very surprising because an interest rate is nothing else than a risk premium. How large is the probability that I get my money back? Well, and the expectation was that the probability that you get your money back investing in Germany is higher than investing in Italy, if you look at the economic policy which was made there. And then we had this same level of interest rates with the start of the euro. Well, and what does it mean from the capital market side? What was, yeah, the rating or the assumption? Yeah. Yeah, definitely. So capital markets believed that the overall risk in the eurozone was more or less the same in every member country. Well, and why was this a problem? Well, of course, if we have looked at the economic performance of the different countries, they still developed differently. But the risk in different, or the economic risk in the different countries was not the same in this time period. What does this then mean? What was the expectation of capital markets or financial markets in this time? Because if we think about rationality, then there still should be, maybe not that much as before, but that we still have differentials between Italy and Germany. Well, then we could say that capital markets believed that member countries would be bailed out within a crisis in the eurozone. Because then it would be rational that you have the same risk. And why was this a problem? And now we are, because I'm talking about this spontaneously, because it is about rules. Well, but we had the so-called no bailout clause in the eurozone. So capital markets believe that there is a bailout, but the rule was that it is forbidden to bail out, so that Germany steps in and is rescuing Greece or Italy. But in the financial crisis, the rule was not applied. Bailout of Greece, South Europe, southern part of Europe, and especially Ireland. So, and formally in monetary policy later on, we will also apply what are the expectations and how do they depend on each other between the different economic agents. And here we have some example where we are setting one rule. So we are saying we're doing something, and the expectations of the economic agents is, well, you can say many things, but I don't believe you. And then there comes an event, here the financial crisis, where something happens. Now, this rule has to be applied or not. And what we see, the expectations of the capital markets were, so to speak, right. And this is quite often that some politicians try to step against the capital movements in the world. I think also it will be quite interesting if Turkey is winning its bet against capital markets. Because what they are doing is not right now anymore in that amount, but in the last 2-3 years, they made some decisions that they said, well, although we have very high inflation rates in around 50 to 100%, we still cutting interest rates in order to stabilize our economy. And this is against economic theory and also against what capital markets would do, because in this case, you will have a capital outflow in your country. And then you have to depreciate your currency and so on and so on. So it is more or less a bet against what general happens in capital markets. And here we had some similar, where everybody saw, well, okay, these are the expectations, and we still said, well, we have our rule. And then we didn't apply it. And also, if we go at this time series, this is the German deficit. And there we had also 3%. This was the Maastricht criterion. Eurozone member states are allowed to have a deficit larger than 3%. Well, in 99, here the euro started, and just 1-2 years ago, further on, Germany didn't meet this target. So, but just after the introduction of the euro, Germany did not meet the target. Well, also this was just more or less directly a situation where we had the question, do we apply our rule or not? And remember, who mainly introduced this rule? Germany. And what happened? Yeah. Yeah, because really, of course, also afterwards, we had higher deficits in other countries, but we directly skipped the rule. So, in general, there was, so to speak, um, a punishment process due to this rule, which at first said, well, we've seen you didn't meet the target, so please don't do it again. So that you just get a letter from Brussels. We have an eye on you. Next year, keep your deficit below 3%. This would have been the first one. And then there would have been a first punishment. You would have got back the money you have to pay when you are again below 3%. Then your interest payment would be gone, and in the end, then the money would be gone. But we directly said, well, we do not want to have this letter. So Germany directly skipped the rule. Well, and in the aftermath, then we could not be very surprised that almost nobody thought about this rule anymore. And this is, of course, also one reason, well, not for the financial crisis, but of course, afterwards, in the aftermath of the financial crisis, then for the European debt crisis. So this is also something about, do we apply rules or do we not apply our own rules? And now, and for this, I made this little talk about rules in general. Today or yesterday, we had one announcement of our High Court in Germany that the budget of Germany of 2021 was illegal. Why was it illegal? Because the actual government took money from the Corona fund and switched it to an investment fund for the longer time, for the change in the energy sector, for investments of in the infrastructure, in education, and so on. So we do not talk about, is this a good idea to invest in education? There, I would always make a thumb up that it is a good idea to invest in Germany into education. But here now is the question, was you allowed to use money from Corona times? Because Germany in 2009, we introduced the so-called German debt brake. And within this German debt brake, we have a very strict rule that in generally the budget of the federal government has to be balanced without loans. So you are not allowed to raise your credit volume in order to finance your investments. So in general, you have to use your tax income to finance all this. And then we have we have some exceptions, and the exceptions are natural disasters and extraordinary emergency situations, and of course, both apply on Corona. But this rule says, well, then this money has to be used within something what happened within Corona and not for long-term investment in infrastructure and something like this. And actually, I was quite surprised when our finance minister announced some month ago also that, okay, this is quite okay that we are doing this. So I'm not very surprised that our High Court made another decision that it is again now the question, what is our government now doing? And yesterday we had a talk in our parliament about this. There, all the parties in the government said, well, of course, we accept the decision, but what will be very interesting now is where do they get these 60 billion euros from? They need now for financing many things. And so we are again in some situation where we will see if we really rely on the rules we gave ourselves. Because if Germany maybe will skip this, and this is of course possible in parliament with a majority of 2/3, you can change the law. And we have roughly 50% of the government, and if you look at the different parties in the opposition, then it might be possible that you get these majority of 2/3 to skip this rule. So we will really see what happens then. And if Germany would skip this rule, this will have also definitely then an impact on the Eurozone and the European Union, because right now it is in the discussion that maybe we should introduce not only national debt breaks, but something like a general debt brake in the Eurozone and in the EU. And the Maastricht criterion of a deficit of 3% is already something like this. Okay. But this only because of the actual situation which we have. Yeah. I think it is a good rule because also when you look in history, and in history we had, or the former Article 109 had more or less the same content. And the content was also that in general you should have a balanced budget. This was also the first sentence, like we have it here. And then the exceptions, when you can overrule these so-called golden rule of fiscal policy, do not spend more than you have, so to speak. There was your budget has to be balanced unless the government says that there is some deviation from the general equilibrium in the economy. Well, and that you are in such a situation, then it was possible that just the government, everybody raise his hands and you have a majority of 50%, and then you can say, well, we are just in such a situation. And if we go back in history, no matter who was in power in Germany, almost always when we had the budget discussions in the parliament, in the end of the discussions, the opposition said, well, you are raising loans, so that is against the law. Then there was a vote about this, and the government said, well, we have a situation that we are out of equilibrium. And this is called, in general, the problem of asymmetry in fiscal policy. So more or less, you always have an incentive to deviate from this general rule that you should have a balanced budget. And since we, so to speak, always do not apply these golden rule, then I think we need some some stronger rule in order that we are in the neighborhood of this, what we also from economic theory think it is a quite good target to meet this. And we introduced this rule in 2009, and then we had this phase of very low interest rates. So we had to pay for our government debt, very low interest. So during the last 15 years, we almost never came in the situation really to apply this rule, because we always had enough money to meet these golden rule. And during these times, I also always said, well, we do not have to talk about much about the German debt break. We have to talk about this debt break then in the situation when we really have to apply it. And actually, right now we are in this situation, and then we will see what our decision almost 15 years ago is really worth. Okay, but then let's go back to monetary policy rules, and this is then a little model, quite famous, and maybe if you want, you can have a look in these papers, and there is another one. Hopefully I have it also, also this one. The model we will look at is explicitly giving in this paper, and this is then about, in the central banks, we also have some rules. And one rule is, for example, that this central bank should be independent from the government. And sometimes we say, well, it would be a quite good idea, so to speak, to have conservative central bankers. What does this mean? With conservative, you mean you have some guy in power in the central bank who looks mainly at prices and do not directly react when something in the real economy happens. Because then, take for example Turkey, we have not a really high GDP growth, even with high inflation rates, start to cut interest rates. And what general problem we have in the part of monetary policy, about this we want to talk right now a little bit, and this is the so-called time inconsistency problem of monetary policy. And in a minute you will see this is very much about expectations within the economy. So what we then at first introduce already, as we have seen the Taylor rule, we in general assume that we have two targets, inflation and output, and now we make a special assumption about the loss function. How does it look like? And there we assume that our loss function is quadratic in the deviations of our targets. And this, you are also doing statistics. What we are doing then here is quadratic deviation from interest rates, net interest rates from inflation, plus quadratic deviation of output. And does this remind you on some function we have in statistics? The sum of quadratic deviations. Well, this is nothing else than something like a variance. Remember, there we had x1 minus x bar squared plus x2 minus x bar squared, and so on. So, in order to use this function is a quite common way in order to use a function where you want to measure some deviation from some specific target. And I think this is also quite important that we motivate in the end the special functions which we are using in economics. So, and what we also use is we use the dependence between the two targets we have. The dependence between output and prices, and this we have done with the Phillips curve. There we have this inverse dependence. So what we now assume is that the loss function of the central bank is just here, the quadratic deviation from our inflation target, and this is the output target and this is then our deviation from output. And we assumed just that it has this quadratic form. Well, and then we have again our weighting between these two aims. So we are just writing in front of the inflation target or the inflation deviation, some parameter A. And of course, then the higher this parameter, the more we rely on prices. So weighting inflation. And we also assume that if this is potential output, that the central bank has an aim not directly on potential output, but a little bit higher than potential output. And the reason for this is also that if we look at output, then of course within the business cycle, then we want to push economy in a crisis, and then we should use a little higher push in the economy than only on the long-term trend of potential output. So in order to make a practical economic policy decision, then it seems quite reasonable that since we want to have an effect in the short run, that our aim is a little bit higher than potential output. Yeah, the 1/2 here, this is just for practical reasons. Since in a minute we will start to minimize these loss functions, what we have to do when we are minimizing something technically, then we have to take derivatives. And if you see here, if we have a squared here, then the derivative will be that the 2 is moving in front of our function, and then the 1/2 here is just that I do not have to write that much because the 1/2 and the 2 are just canceling. Because also this is an ordinary measure, it doesn't matter if I write here, in front of the bracket 100, 1,000 or whatever, because this is then just a parameter which doesn't matter about the necessity conditions to have an optimum. Okay. Then, in order that I also do not have to write that much, let's assume that our inflation target is just 0. We know in general it is around 2%. And what we now want to do is that we just calculate the outcome if we have rational expectations. What does it mean? Rational expectations just mean that our expectations meet the actual inflation, so that we, so to speak, do not make any mistake. And then we see what happens. We will see what happens in this economy, given that the central bank is minimizing this loss function. And then we will compare this situation to a situation where we are just setting the inflation rate on target, on our target inflation equals 0. And then we will also see that this cannot be an equilibrium, and afterwards we want to discuss, I don't know if we come to this today, how we could maybe achieve that we are on target for the inflation rate. So let's start. So I take just this function here. And we use also the Phillips curve. And we skip this one since we set it to 0. So pi star is set to 0. Well, what do we have here? Actually, we have nothing else what you already have quite often seen, at least in microeconomics. We have a loss function. This is depending on two variables. And we have a condition. Also depending here on y and pi. So what we now have to do, minimize L of pi y subject to y equals y star plus b minus pi minus p expected. And well, compare this with maximize u of xy subject to m equals px times x plus py times y. Do you remember this? There maybe you have then written x to 1/3 times y to 2/3. Subject to 1000 is 2x plus 3y. I think you have done this in your exam, or not? So this is just the utility maximization, maximization subject to our budget. Restriction. So what you have done here is just y and x. This is your budget restriction, and this were your this were your indifference curve, and then you moved it out as much as it possible, and this was your household optimum. Well, and nothing else conceptually we are now doing. We have some loss function depending on two variables, and we have one condition where we have a dependence between these two variables. Well, and this can be solved via Lagrangian multipliers or via the total differential. Remember here, you had just that the relation of the marginal utilities, dy equals the price relation of our two goods as the optimum condition. This, I think, my colleague introduced at first second is it? Gauss's law. Maybe you have heard this? Yep, at the optimal condition for the household. And yeah, actually we are just looking for something like this. But what we also see is we have here just a linear condition. This is only just a quadratic condition. We can solve this also if we just move in our y in our function here. Because then the output is vanishing and we have only one dependence on inflation anymore. Okay. Or this is the Phillips curve putting pk into the loss function. So this we will do. Then we have L now only depending on pi equals 1/2 times a pi squared plus opening brackets. Now we have to put in the Phillips curve y star plus b times pi minus pe minus ky star brackets closing squared. So in this case we can put these two together. So we obtain 1/2 times a pi squared plus b pi minus pi minus k minus 1 times y star squared. So now we have a function only depending on one variable. In order to minimize it, what we have to do technically, if you have just f of x, minimizing what you are doing. Yep. Derivative, yeah. Just the derivative, calculating the derivative with respect to pi, and then doing what? Well, if we, and we have here quadratic functions, if we take just f of x, x squared, then we are looking for this point 0. The derivative is just the slope of our function. So what we are looking for is where the slope is a horizontal line. Because then we have the minimum. And the slope is a horizontal line when it is equal to which number? Yep, 0, of course. So then L prime of P has to be 0. This is condition to have an optimum. Well, then let's do it. So we have to look at, let's do this in red, up, at every part where we have pi. So the first one is quite okay. There we just have 1/2 in general, and then pi squared, the derivative, is f of x equals x squared, then the derivative is yep, yes. And well, I already talked about this because then we have the canceling of these two numbers. Well, but here we have that the pi is within two brackets. What you have done to apply, which rules for the derivative you have to apply. So plus, if we have here that 1/2, we can just write it down because it's just a parameter. But if you have f of x is x minus a squared, what is then f prime? Or even we should write here a 3 in front of this. Yep. Yes. The a. But is it really true that this parameter just vanishes? So this a1 here. Yes. So we have to write down 2 times the outer derivative from the bracket x minus a, and now the inner derivative. So we have also to calculate the derivative of 3 times x. And what is the derivative of 3 times x? So if you have f of x equals 3x, what is then f prime? It is just 3. So this is 3, and overall we obtain 6 times 3x minus a. And this is chain rule. F of g of x, then, or let's say h equals, then h prime is f prime of g of x times g prime of x. This hopefully you have shown in school in class 12, I think. And hopefully you have redone this in your mathematics course. Yeah? Because these first derivatives you very, very often use in economics, because it is all about this optimizing some target function with respect to some restrictions. Okay, so this 2 in front times 2, writing down the whole bracket. Here we are. Let's take this one. B times p pi minus pi e minus chi minus 1 y star. And now we have to calculate the inner derivative, because still we have here also our pi. So what is the derivative of b times pi minus expected inflation? So what we need now is we have the function f is b, f of pi is b times pi minus pi e. What is then f prime with respect to pi? So expected inflation we take just as a number. This is given. B is also given. So think of a function f of x is 4 times pi minus 3. What is then f prime? Yep. So only one? Really? No. Well, you can calculate this as 4 pi minus 12. So the 4 doesn't vanish. It's just 4. So, and now identify this is B and this is pi e. What do we obtain then here? Yep. Oh, sorry, here, this is only PE. This is just also a function. So this is our 4 and this is our minus, this is our 3. We take expectations as given. Oh, this I should also have written down in front. Given also, this is also a condition PE, pi e. Hmm? Well, 3 is vanishing, so we do not have any pi e anymore, and we are just left with our b. So this we then have also to multiply once with b. Well, and we are interested in what is the optimal inflation rate to be set by the central bank. So this has to be set to 0 and solved for pi. So fortunately, all these 2 cancels. And then let's see where we have here our pi. So this is then a pi plus b pi. Then we have this, and here we have another b. So it is b squared pi. Then minus b times be times this b here is minus b squared pi e minus k minus 1 times b, this one also here, times y star. And this has to be 0. In order to solve this for pi, let's take this together. Then we have a plus b squared times pi. And then in the end, we want to have pi only on one side and all other parameters on the other side. We make plus this to have this on the other side. So b squared pe plus k minus 1 times b times y star. Well, and we only want to have pi on the left side, and then we have pi equals b squared over a plus b squared pe plus k minus 1 times b over a plus b squared y star. So, and this actually was quite important. This assumption that we take expectations as given, because what we now have is the reaction function of the central bank depending on expected inflation pi e. Well, and this we have now to take. Also, we assume that society is knowing the loss function of the central bank. So we are in a transparent economy. And for this, we assumed calculate social losses under rational expectations. So now we take our reaction function and then under rational expectations of the society, we have to calculate P E equals pi. Now we take, so to speak, the other view and say, well, we are knowing what the central bank is doing. So I believe that they rely on their rules. And let's see this. How does this looks like graphically? That we write down here pi and here the expected inflation. How does this function looks like? So all other parameters, we are looking only at the dependence on the expected inflation. What kind of function is this then? A, B, K, and Y star are given numbers. And all these given numbers are positive. This we have also assumed. What is it? Is it a square root function? Is it a logarithm? Maybe it's too easy. Yep, it is just a linear function. And where does this linear function start? when I want to draw it here in my diagram. Oh, we also assumed that k is larger than 0 and the rest is positive. Yep. No. Just put in 0. Pi e equals 0. Then you obtain. Yep. Oh, here are. Yes. So this is just the cut of the vertical axis. Remember our linear regressions. So here we have chi minus 1 times b over a plus b squared. And then it is a linear line, and this is the slope. And what we see here, it is b squared divided by a plus b squared. A and b are both positive numbers. So a plus b squared is larger than b squared. So the slope is lower than 1. So this is pi of pi e. And I think you have heard just my macro lecture. Do you remember how we can now draw this function here? Pe pi equals pi e in our diagram. Yes, and where it starts? At 0, at the origin. And what kind of slope? This one? It is just 1. Here we have just a 1 in front. So this is just the diagonal here. And this is pi equals pi e. So this line is just the number, or is just the points where we have the possibility that we meet rational expectations. And then we have an explicit function for our reaction of the central bank. And so this cut here is rational expectations equilibrium. Well, 3 minutes. Hopefully I will make it. So now we put in this here. So setting pi equals pi e. Then we have pi is, and that I do not have to write that much. Let's set that this is a new parameter a, and this is just a new parameter b, since these are all fixed numbers. So then I have a pi plus b, solving for pi. We obtain pi times 1 minus a equals b, and pi star. So equilibrium inflation rate is just b over 1 minus a. And let's insert all our numbers. Then we obtain k minus 1 times b times a plus b squared over 1 minus b squared over a plus b squared. This looks a little bit crazy. Then we write k minus 1 times b over a plus b squared over, putting this on the same denominator, we obtain a plus b squared minus b squared over a plus b squared. This and this is canceling. This is canceling, and we obtain k minus 1 times b over a as our equilibrium inflation rate. 1 minute left. And now let's put this into our loss function, and then we see what kind of loss our central bank has. So then L of pi equals pi star. Then I have to use this one here. Oh, here I had my diagram. This we also don't need. Well, we have, let's take again red. We have pi equals pi e as an assumption, rational expectations. So this is 0, this cancels, and then putting in here k minus 1 times b over a. So we obtain 1/2 times a times k minus 1 b over a minus k minus 1 y star. Is this all right? Here is a square again. Sorry, this I have forgotten. And here we have also the squares. Sorry, I was too fast because I haven't copied the squared. So here we also need the squared and this square. Well, this will take a little bit longer. I just ask you, should we do it now or next week? I don't know how much time you have. Yes, because this will take, I think, about 5 minutes or so, and maybe I miscalculate during this. And so this is then homework. Please calculate this and compare these losses if we directly set in pi is 0 and we have pi e equals 0. So if we just would directly set inflation to 0%. Okay, then thank you very much for today.